Good morning to all. This is Maulika, Assistant Professor, Department of Physics from St. Joseph College of Arts and Science for Women, Hosur. In this video, I am going to explain about both natural radioactivity and artificial radioactivity. Yes, who discovered radioactivity? The radioactivity was discovered by Henry Becquerel in 1896. He found that a uranium salt wrapped up in paper emitted certain penetrating radiations which affected a photographic plate. And he observed the radiations were given off spontaneously without any need to any initial excitation of the uranium salt. So he declared that the radiation is not influenced by any external agency. Further investigations are did by the scientists Madame Curie, Pierre Curie, and Rutherford. The heavy elements like uranium, polonium, radium, thorium, these elements are well exhibited this phenomena. Then the radioactivity involves the spontaneous transmutation of one element into another. Then we have two types of radioactivity, that is natural and artificial. The phenomenon of spontaneous emission of highly penetrating radiations from heavy elements of atomic weights greater than about 206 occurring in nature is called natural activity. That means natural radioactivity. So, the elements which exhibit this property are called radioactive elements. Uranium, polonium, radium, thorium, these are the examples of natural radioactive elements. And the atoms of radioactive elements emits radiations composed of three distinct kind of rays, that is alpha, beta and gamma rays. In this process, the elements breaks up leading to an irreversible of self disintegration. This activity is spontaneous. Radioactivity is unaffected by any external agent like high temperature, high pressure, large electric and magnetic fields. The modern technique of artificial transmutation of elements has been able to produce radioactivity in many other elements, much lighter than those that occur in nature. Radioactivity induced in an element by bombarding it with alpha particles, neutrons, protons, and other particles or radiations is called artificial radioactivity. Hence, there is a distinction between natural radioactivity, that is elements as found in nature, and induced radioactivity artificially produced. But whether be its origin, the activity is always spontaneous. The artificial radioactive elements usually but not always have a short lifetimes. They emit electrons, positrons, and other particles as well as gamma rays in the decomposition. But in natural radioactivity, they emit alpha, beta, and gamma ray particles. This image shows the existence of three distinct types of radiation is demonstrated by a simple experiment. A small quantity of radium is placed at the bottom of the small hole drilled in a lead block. A fairly parallel beam of radiation from ore will issue through the hole. This lead block is placed inside an evacuated chamber to avoid absorption of the rays. A photographic plate is placed at a short distance above the lead block to receive the rays. The strong magnetic field is applied at right angles to the plane of the figure and directed away from the reader. After a fairly long exposure, the photographic plate is developed. Three distinct lines will be found on a photographic plate. So the alpha particles will be deflected towards the left, and it's indicating that they are positively charged, and the beta particles will be deflected towards the right, and it is indicating they are negatively charged. The gamma rays are not deflected and hit the plate it is straight only. So this shows that the gamma rays are unchanged. These rays are called neutral rays. If an electrostatic field is applied in place of the magnetic field, the beta rays are deflected towards the positive plate and the alpha rays towards the negative, and similarly gamma rays do not blend at all. Let me discuss about the properties of alpha, beta and gamma rays. First, what is alpha rays? Helium nucleus consists of two protons and two neutrons. So this helium nucleus is called alpha particles. The charge of the alpha particle is always positive, and the ionizing power of this is 100 times greater than beta rays and 10,000 times greater than gamma rays. The penetrating power of alpha particle is very less, and um, these rays are deflected by both the fields, and their speed range from 1 by 10 to 1 by 20 times the speed of light. Then we are coming to beta rays. The electrons are called beta rays. The charge of the beta rays is always negative. The ionizing power of beta particle is comparatively low. The penetrating power of the beta rays is greater than that of a alpha rays. They can penetrate through a thin metal foil, and it is deflected by the both fields, but the direction of deflection is opposite to that for alpha rays. The speed range of beta particle is 9 by 10 times the speed of light. Then finally, gamma rays. The gamma rays are electromagnetic waves consist of photons. Photons are light particles. The charge of the gamma rays is neutral. The gamma rays don't have any charge, does not have any charge. So the ionizing power of gamma particle is very less, and they have gamma rays have a very high penetrating power greater than that of beta rays, and they can penetrate through thick metal blocks, and gamma rays are not deflected by both electric and magnetic field, and they can travel with the speed of light. So this is the basic properties of alpha, beta and gamma rays. Thank you.